Today we're going to be talking about how the SQL Server engine thinks. This is a level 100 class. This is an introductory class where we're going to cover some basics. You won't hurt my feelings if you go bail out to the storage session next door. Although I will tell you that most of my clients don't know how this works either. A lot of stuff in here comes as a surprise to folks. A little bit about myself. I'm a Microsoft certified master, which just means I like to talk a lot and I preach a lot, and I've made a lot of expensive mistakes. Now I want to make sure you don't make those same mistakes that I made. Today what we're going to be talking about is clustered indexes, non-clustered indexes, statistics, and sargeability. Some of the foundations of how we run queries in SQL Server. And I'm going to be teaching it to you with you being the SQL Server and me being an end user giving you queries to run. You are going to be running the Stack Overflow database. This is a table here, and those handouts that are on the edges of the rows, because I only expected like 3 people to show up, plus maybe my mom. I didn't print out copies for everyone. Grab just the white pages and split them up across the rows. Don't take the gray or black pages yet, just the white pages. These are the clustered index pages for the Stack Overflow users table. Stack Overflow makes all of their data available publicly, so you can download it and use it in your own demos too. The first thing that you're going to notice is that the data is sorted by ID going down the left-hand side. The clustered index of our table is only on one field, the ID field that has the key up at the top. But the clustered index has all of the fields on it. The clustered index is the table. It's the order that we sort the table in. And you'll notice that I've given them to you in the form of pages. Everything that SQL Server does, it stores in 8K pages, in memory and on disk. When you go to update someone's record, if you pull Jeff Atwood, ID number 1, and he decides to change his location from California to New York, SQL Server is going to get that page off of disk, put it in memory, and make that change to the row, then flush the entire page out to disk. SQL Server's smallest unit of caching in conventional tables, not the hekaton stuff that Kaylin Delaney described this morning, but normal tables, the smallest unit we work with is entire 8K pages. The next thing that you're going to notice is as you go down the right-hand side, there's the About Me field. In Stack Overflow, we let anyone write long letters to grandma in the About Me field, bragging about all the cool things that they do. That data is stored off-page somewhere else, off-row, because in SQL Server, we are going to just work in 8K chunks. When you build a varchar max field or nvarchar max, that's going to go somewhere else when you put a lot of data into it. And as we're going and querying this data, I would have to go jump over to wherever that other page was. We're not going to talk about that kind of off-row data today, but I just want to make you aware of it because it makes a difference as you design tables. The first query you're going to get is select star from DBO users. And what I'm going to have you do is build your execution plan in plain English. Think about how you would accomplish this if you had a stack of 1,000 of these pages in front of you. Well, what you do in plain English is you'd simply read through all of the pages, saying every row out loud. Come on down. There's no space left, but you can sit up here on the stage. I'm just kidding. So could you parallelize this work? Since there's a lot of us in here, I could give 100 pages to you, 100 pages to you, 100 pages to you, and have all of you work on that exact same thing. I could divide that work out. SQL Server can't do that for all queries. We're going to talk about that more in a minute. So this is how SQL Server's execution plan looks. We like to say that SQL Server execution plans suck. They suck the data from right to left. So the thing that we're trying to accomplish is this select over here. He grabs all of the data from our clustered index. This is the only copy of the table we have yet. You'll have more copies here in a minute. So SQL Server is going to scan the clustered index in order to accomplish this query. Because there's only one way we can do this. It doesn't really matter what order we get the data in. We're just going to scan all of these pages. So as I add additional stuff to the query, I'm going to color code it and bold it so that it'll stand out what we're changing. Now I want to just select the ID field where the last access date is greater than 7/1 of 2010. Think for a second about how you're going to accomplish this query. So in plain English, what you're going to do is you're going to read through all of these pages, checking to see if the last access date matches. Now, because we're human beings and we work with spreadsheets, we think we're just going to scan down the last access date column. That is not how SQL Server works. SQL Server doesn't store things in nice columns on the page. It jams things in as hard as it possibly can. There's no additional work in order to do this. We're still just going to have to read through and examine every row, but I don't want you to think that there's an index for every single column. I'm just making your life easier with these spreadsheets. So let's look at how SQL Server executes that exact same plan. SQL Server still scans the clustered index because that's the only access method we have. Now, SQL Server's already complaining because SQL Server is very lazy and SQL Server doesn't want to do any extra work. So he's saying, I wish I had an index, a copy of the table, sorted by last access date. That's what that missing index piece means. Our query would have been 96% faster if we had a copy of the table sorted in that order. But that doesn't mean that this query was harder than the last one. It wasn't. SQL Server had to do the same amount of work. And notice that SQL Server still has to say things out loud. It has to say the ID of every row. There's no hint on the execution plan how much or how little you're returning. You can go deeper into the execution plan and grab some of this stuff, but what I want you to take away from that is it really doesn't change the way we execute the query. The same basics still apply. Let's take the next query. And I want you to think about doing this as a human being. Don't just think, oh, I'd read through all the records and write down the last access date. No, how are you really going to pull this off? And imagine that you had 1,000 of these pages in front of you, and I was waiting on you to execute this. So what you're going to have to do, because I love you people, you're very attractive, but you're not that bright. You're going to have to write down all of the IDs and last access dates that match what you're looking for. You're going to read through this entire clustered index, and then you're going to be writing that matching data down somewhere and then sorting it, because we don't have enough memory to remember all of the rows that are involved. So look at how SQL Server does that. SQL Server goes out into the public toilet, which is its scratch pad, TempDB, where all kinds of nasty, filthy things are going on. It's not just about you creating temp tables. The engine uses it, read committed snapshot isolation uses it, always on availability groups uses it, rebuilding indexes in TempDB uses it. All kinds of engine stuff relies on TempDB. This is SQL Server's scratch pad, where it's going to go do a lot of sorting and joining. I am not guaranteeing that every time you do an order by, it's going to hit here, but we like to think all this stuff is happening in memory. It's not. SQL Server uses memory for 3 things: caching data, caching execution plans, and working on your queries. you don't get knobs to configure how much of each of those SQL Server uses. So often when your queries take flight, you get kilobytes of memory, not megabytes or gigabytes, because you're not the only person using that SQL Server. The next thing I would think about is, when do we actually sort this stuff? Well, if I'm going to parallelize this work, if I'm going to break it across multiple attendees in the room, I don't really care if each of you sort it. I'm going to have to sort it all again when I collect your work back in. So SQL Server is going to do this sorting after it gets done, as you can see in the execution plan. So SQL Server starts with this clustered index scan, again, the only copy of the data I have. It's going to write down everything in the public toilet and then do a sort. Man, this is going to be a lot of work. This is our first takeaway for performance tuning. When I see a table that only has a clustered index and nothing else, just one copy of the table, every query I do on this is going to suck. There's going to be ways that I constantly access this data, and I want to pre-sort it for SQL Server instead of having to constantly write out to TempDB to do all my sorts and joins. Let's take a look at another query. I've only changed one thing about it. This is how I always wrote queries when I was a developer. Select star from users where last access date is greater than 7/1/2010, order by last access date. Does that change the way we execute this query? We don't really have a choice here. We have to do it exactly the same way because I only have a clustered index, but now this query sucks. Because is it going to take more time to read? No. I still have to read through all of the pages in the exact same order. But does it take more time to write into the public toilet? Yes. I have to write down every single field, including that big about me that's ginormous. This thing is huge. I'm going to write all of that down into TempDB, and then I have to sort all of that data instead of just a nice tight list of IDs and last access dates. Does it take more time to output and say out loud? Sure, that's usually what DBAs get frustrated with. They say, oh, you shouldn't read all the data back out. That is the least of our problems when it comes to select star. The real problems are those middle two, and let's take a look at just how bad those are. I can compare execution plans in SQL Server Management Studio. The top one is when I just selected ID. The bottom one is when I did the select star. The shapes of the plan are exactly the same because SQL Server has to do this work and then sort it. When you glance at this, you think that sorting 32%, sorting 99%, this one must be 3 times more expensive. But it's much worse than that. If I hover my mouse over the root node of the execution plan, the thing I'm trying to accomplish, I get estimated subtree cost. This, a long time ago in a galaxy far, far away, this meant the number of seconds it would take a query to run. That's not true anymore. It's just a general measure of CPU and I/O costs. It's not really good for comparing one server to another, but it's very good for comparing queries on the same server like I'm doing here. Top query, just selecting ID, the cost is 6.5. Bottom query of selecting star, 331, or roughly 50 times more expensive to do the select star. Or to put it another way, for every one of these bottom queries I run, I could have run 50 of the top queries. You want to make performance happen, you want to make scalability happen, you only pull back the data that you need. Avoid scribbling so much data into the public toilet. Whenever I'm dealing with queries that I'm trying to tune, first off, more problems, more fields, more problems. And what I want to do is go through and make this all pre-built so that I don't have to worry about this. Because if I'm constantly querying by last access date, let's make our lives easier. So I'm going to now give you an additional page. This is the black page in your handouts. And of course now, because people have packed it in, there's not that many black pages. I'll show it up on the screen here in a second so that you guys who weren't privileged enough, see, this is why you get here early. No, you had to come in fashionably late. No paper for you. You only get clustered indexes and nothing else. So the black page is an index, a non-clustered index on these two fields. This is the create statement I used. Create, and I like to name my indexes based on the fields that they're on. I created it on last access date and ID. And I left off the users table here just to make it clear. This is the actual index. So the first thing that you're going to notice here, aside from the fact that the color is black on the paper, is that you can fit 4 times as many columns or 4 times as many sets of users on the black one as we do the white one. Because I've got less fields. I'm not storing all of the crazy data that I have on the clustered index. This is more dense. I'm able to cache more rows in memory, but of course I have less data about each row. I don't have all of the fields. The second thing you're going to notice is I now have 2 copies of my table. Every time I do an insert, update, or delete, that's twice as many writes out to storage. A lot of us have 5 indexes on a table, 10 indexes, 20 indexes. I have a client with 176 indexes on a table. And when you insert into that table, your storage groans in pain and weeps in the data center. That's why they don't let you in the data center, because there's so much crying and weeping going on. It's just like when I grew up. So I don't want to have any extra indexes more than I have to have, but this may help me perform a lot better as I get more queries. So now I've got another query again. Select ID from users where the last access date is greater than 7/1, order by the last access date. Given those now that you have 2 indexes, you have your white copy and you have your black copy, how do you go about executing that? Show the query again for a second. So your plain English execution plan is you don't need to touch the clustered index. All you need to do is seek directly to the date that matters on this one and read the rows out in order. You don't have to hit tempdb to do any sorting. Everything's already sorted for you in just the order that you want. Now I'm going to show you the real execution plans in here in a second, but there's something else you should be aware of. What happens if over on my users table, people are frequently doing updates and deletes and trying to lock rows, and I don't even have to touch that because I'm hammering this query for selects or this index for selects all the time? I can get more concurrency with the right indexes. If people are always grabbing locks over here to update their name, for example, or update their about me, because people like to change their bios all the time, it doesn't slow down the selects that I'm doing over here. So here's how SQL Server does that. We have now just a seek on our non-clustered index. Here we go, it's the index that I just created, and I'm able to jump directly towards it. And if I compare this, the top is my before. Remember when I was just doing a clustered index scan and I was just getting ID, the cost was 6.5. It jumped up to like 330 when I grabbed all the fields, but it's just 6.5 for ID, 0.08 when I'm able to do the index seek on my non-clustered index. 80 times faster. It's hard to make your server 80 times faster. It's hard to make your storage 80 times faster. It's hard to make your queries 80 times better. This is the way that we do incredible performance tuning very easily in SQL Server, is by having exactly the right index for our most frequently occurring queries. Now, next up on that, I just want to point out that this is technically called a covering index, but only for the query I just gave you. That means that the index is covered, the query is covered by this index. All of the fields I needed, ID and last access date, are all included in this index. But it's not really an index. All you have in your hand is the black page, and when you go to seek on this page, you're really doing a scan. You're reading through all of the records. There's a separate part to indexes, the B tree, that's this whole navigational structure of how I get exactly to the right page. You don't have to understand how it works. This is more of a mechanism of how SQL's internals jump directly to the right page. But don't make indexing decisions based on that part. Focus on what's on these leaf pages, what the SQL Server engine is going to pull for your select queries. Next query that I'm going to give you, and you still got both copies of the page here. Give me ID, display name, and last access date, where the month of last access date equals 7 of July. Think about how you're going to accomplish this. Now, I know when I was a developer, I used to think that the database would be smart enough to use my index and go to the 1st July, read to the end of that July, skip ahead to the next July, move on. SQL Server's way lazier than that. SQL Server bails out much earlier and says, I can't efficiently use an index with these search arguments. Sargable, this is one of those made-up words like compressive and performant that consultants like to use. When this thing is not sargable, that means I'm going to be scanning through the entire index. Really, I'm going to be using it, but I'm going to be using it the same way my business partner Jeremiah and I use rental cars in Las Vegas. And you don't want to see how we use rental cars in Las Vegas. Love America. So I've got a blog post explaining how this concept works and what things are sargeable and what things are not sargeable. But some of the biggest loser takeaways here is comparing Unicode strings to regular strings, dates sometimes to strings, uppercase and left. You would think that SQL Server would know that when I take the left of last name, I could just jump to that part of the index. Not so much. Same thing with uppercasing. Even if your database is case insensitive, SQL Server says, well, you want it uppercase. I guess I'll uppercase every single row in this entire table every single time. And SQL Server does not cache the output of your queries. SQL Server caches these. This is really important. SQL Server does not cache the output of your queries. If you run the same query 100 times in a row, even in a read-only database, SQL Server will rebuild your results every single time. This is why we're so concerned about getting our data types to match, for example, so that we know we can seek directly to the right thing and not use these functions where SQL Server has to recreate the wheel and recalculate this stuff every single time. Let's make it just a little bit simpler. Let's go for just ID, display name, and last access date, where the last access date is greater than this, order by last access date. Armed with the two indexes in front of you, the clustered and the non-clustered, how do you go about accomplishing this? The non-clustered index, the black copy, doesn't have display name and age. So what most people will decide to do is first use that index to go through and make a list of all the records that match. They will write down the ID and last access date sorted in order, and then go back and look up the matching data over from the clustered index. They'll do this back and forth boogie. Here's what that looks like for SQL Server. Now we have our first double-decker execution plan. SQL Server starts with the non-clustered index seek, looking up those rows, and then second, it will go back and do lookups for all of the display names and ages involved. This is a classic index tuning pattern. Whenever you see this, you could make your query blazingly fast by just adding the fields you need to the non-clustered index, grabbing whatever display name and age or whatever fields are out here and adding them into the index. But there's a drawback to that. There's actually a few drawbacks to that. When I do that, suddenly I make the index wider. I can store less data per page. And if people frequently update one of those fields, like age, that changes every year, I'm going to have to go back and change that index constantly as well. That's not the only way SQL Server could execute the query. What did SQL Server decide to do here? SQL Server looked at this and said, you know what? The number of rows that are involved make more sense for me to just read this once instead of doing this back and forth boogie. Because what if, think about the dates, looking at your black non-clustered index, what if the parameter that came in specified all of the rows that were in your table? Say there's 100 of them. You're going to do one read from the non-clustered index, then you're going to go do 100 lookups in the clustered index. SQL Server's lazy. It wants to do the minimum amount of work it possibly can, and it wants to get in and out of these tables as quickly as it can, because it wants to let other people get locks in these tables. SQL Server would rather write down the entire contents of the table into TempDB and then do the sorting there when it knows it has a whole lot of rows back and forth. Because when SQL Server looks at all of the work it has to do to look up back and forth across hundreds or dozens or thousands of rows, it sits back and says, sorry, ain't nobody got time for that. And then it just bails out and does the table scan instead. So what determines why SQL Server would bail out and do that? That's where statistics come in. For every single index, if I go into SQL Server Management Studio, every single index on a table has a matching set of statistics. So for example, I created IX last access date. SQL Server turns around and creates a matching statistic with the same name. If I frequently query by other fields, say that I constantly query by username and password, but I don't have an index on that, SQL Server is smart enough to add its own statistics. That's where these WASys statistics come in. So what are statistics? I'm going to show you, we're going to zoom in here in a second to make this easier to read. But the thing I want you to take away is that we're going to look at it with a command called dbcc show statistics. You don't have to write this down. You don't have to understand how to run this in your system. You can, it doesn't hurt, but knowing that they're there is what's going to help you design better databases, better indexes, and write better queries. When I run this, I have to pass in the name of the table and the name of the statistic. It's a little confusing because every one of my indexes has a matching statistic, but I'm looking at the statistic last access date. I keep wanting to walk over to this thing even though I have a clicker. So I've zoomed in a little bit on just the output of dbcc show statistics, and it returns 3 sets of rows. The top row tells me stuff about that statistic. So when this statistic was last updated, October 14th of 2010, at that time, I had 276,000 rows in my users table, and I looked at all of them. When SQL Server gets started, looking at smaller tables, it'll scan the whole entire index to get a perfect picture of statistics for that. But as your table gets bigger, SQL Server just starts sampling like a political pollster, trying to guess what the output is going to look like. And it's about as accurate, which is to say, not very accurate at all. SQL Server updates these statistics for you automatically when about 20% of the data in your table changes. Think for a second about a database with 5 years worth of sales history. I'm doing my spirit fingers there. 5 years worth of history. 20% of that is 1 year, meaning by default, you'll only get stats updates about once a year. And the data in this statistic will be old the rest of the year. When those statistics updates happen, when they fire off automatically, all of a sudden SQL Server says, everything I know about the users table is different now. Every query that references the users table, I'm going to throw out that execution plan and build new ones because the shape of this data has changed. And this is one of the reasons why we think everything's doing great on the server, and out of nowhere, all of a sudden a query starts becoming slow. Because if you trip this threshold, and all of a sudden you get new execution plans, whammo. You might get completely different execution plans based on what's in here and based on whatever parameters the user passes in first for that query. When you call a stored procedure, SQL Server builds an execution plan based on the first set of parameters that come in. And it saves that execution plan for every single time someone executes that stored procedure. So we are rolling the dice whenever statistics get updated. We're rolling the dice that whoever calls it first is going to use a good set of parameters. But if they use a weird set of parameters, and I'll give you an example. One of my clients, every time their application started up, it got sales history going back from like 1899, and it would pull it all forwards. But when their stored proc ran at the beginning, it used a parameter of get date. It says, get me all of the current sales moving forward. There are no sales in the future, so SQL Server would build a beautiful execution plan for no data. And then as soon as they actually ran it with real parameters, going all the way back through the history of time, the application would kick SQL Server in the junk because it just had no idea how to deal with that much data. This parameter sniffing topic is really important in SQL Server. There's a lot going on there, and this kind of ties into that. So this tells me that when the object was up, the stats were updated in October 2010, I had that many rows. The statistic is on last access date and ID. Now would be also a good time to mention that if I look back at that black non-clustered index, the black non-clustered index is on both last access date and ID. But I didn't really have to specify that. The primary key, the clustered index on my table, is ID. So if I would have just created this index on last access date and nothing else, SQL Server would have automatically added the ID in for me because it has to be able to get back to the non-clustered index. I actually like to add ID in here when I'm doing these demos just to make it crystal clear how these two tables join together. But the stats, we'll look a little further deeper. The stats down here talk about ranges of data. So for last access dates of exactly August the 1st of 2008, there is one row that is equal to this data, to this date. In the bucket between October 25th and August 1st, in this range, there are 1,222 rows. There is only one row that is equal to this high key. There are 1,222 different date values inside this range. So SQL Server is going to use this data to guess. If I said, show me all of the rows that are as of September 15th and prior, there's no record in here for September 15th. SQL Server is going to look at this and go, September 15th, that's in between these two things. Well, I'm going to guess there's about 600 rows inside that range. SQL Server makes guesses, does the best that it can. SQL Server builds execution plans without looking at the data itself. It doesn't open up indexes to build these execution plans. It just looks at statistics in order to build those. Then, as I look further down, I've got, if I scrolled all the way down, 155 different buckets here that describe my data. I only get a maximum of 200 different buckets, and that's it. SQL Server builds the best picture it can of your data using 200 buckets. But think about for a second, what if you're Amazon.com? What if you're a big online sales provider and you have an index on your sales history table, everything you've ever sold to everyone in the world, and that index is on product ID. It's either a GUID or an identity field that is an ID for Lady Gaga's record, the Blues Brothers movie, my book, which sold 4 copies, and all of these things that are all lined out by ID. The IDs have nothing to do with each other. My book's ID could be one away from Lady Gaga's records, and the sales were very, very different. But SQL Server only has a limited number of buckets here, and when you think about the huge number of things that Amazon sells, 200 buckets isn't enough. So when I say, show me all of the sales for Brent's book, I may get an estimate of like 4.5 million just because it threw me in the same bucket as Lady Gaga. And of course, the execution plan for that would be very incorrect, although it'd be quick because I only have like 4 copies. So this is a problem in SQL Server. There's a way around it called filtered statistics, but you only want to start playing with that when you can prove that this is the biggest problem with building your execution plans. Now notice I said that my index was on last access date and ID. And when I look at the description of the statistic, it says last access date and ID. There is nothing about ID here. Statistics are about the first column in that statistic, and that's it. When you create an index on a whole bunch of fields, this is one of the reasons why they say put the most selective field first. Think about if I had an index on all of the people in the world, and I had an index, or I had a table with all of the people in the world, or even Stack Overflow's users table, and I added an index based on gender. Say it was gender and then display name. And in gender, I'm only going to have 3 values, male, female, and boy George. And so the numbers are going to be roughly half of them in male, half in female, and 1 for boy George. And that's the only thing SQL Server is going to know about that index. So if I say select star from users where last name equals Ozar and gender equals male, it's just going to look at this and say, I got 50 million guys, I have no idea how many of them are Ozar, and it's going to build a really bad execution plan because it doesn't have good statistics on the fields that are selective. So if you have a non-selective field like status, country code, is active, yes or no, this is one of the reasons why you don't index that as the first field. You may have multiple fields in the index. Don't necessarily use the generic one first unless that's the only thing you're filtering for. If you constantly show me, say, select star from orders, where is processed equals 0, because there's only a few records that haven't been processed yet, then it makes sense. But if you're filtering for is processed and something else, maybe the something else is what should go in the leading column. Here's a good time to stop for questions. Anybody have questions so far? I know once I start going, it's hard to interrupt me because I'm all dancing in the aisles. No questions so far? Don't feel stupid. Yes? Great question. So what happens if we manually create statistics? So we created an index on gender, something that's not very selective. And then we go manually create statistics on something that is selective, like last name. This gives SQL Server better estimates about how many rows will come back, but it's still going to have a crappy job going through the index in order to get to exactly the rows that we want, because it's going to go to male first and then go find Ozar. If I know that I always query by display name, then I'm going to want to put that display name first and then the gender or whatever afterwards. It gets tricky. This becomes like an art and a science. Which indexes should I have? Which fields should go first? And there's not a lot of good rules out there that give us guidance on how we should do that. So my guidance, and this isn't written down anywhere, but just from my work as a consultant, I usually get nervous if I see more than 5 indexes on a table. I start to ask questions about how many copies of the table we really need. I have some clients, Stack Overflow is a great example, where they can have dozens of indexes on every single table because they cache all of the data in RAM. Every SQL server has at least 384 or 700 some gigs. And then they have all solid state drives. So every write finishes in less than a millisecond. We don't care how many indexes we put on. It's all about getting the data to finish quickly out for queries. You guys don't have that much money to throw at your hardware. You're not all working for .coms, although you all dress very nicely. You appear to spend your money on clothes instead of hardware, I suppose, but a lot to be said for that. Oh, more questions before we go on. Yes?
The primary key is always included. Will the index be smaller if I just create a last access date?
Great question. Will the index be smaller if you only create it on last access date? Because you're talking about indexes, not statistics, right? Yes. So I'm going to go back and show the black page for those folks who got here late, just so that they can see what we're talking about here. Come on back to me. Come on back to me. We're going way back. There we go. All right, so what happens? ID is always included no matter what. Will my index be smaller if I say just created on last access date? The leaf page, the page you have in your hand, is still going to be exactly the same size. But as I go higher in the tree, or lower in the tree for Kendra's illustrations, these pages may not include the ID. They will only include enough data to make it unique to get to exactly the row. You may save a tiny amount here if you take that approach. And I would take that approach. I mean, I only do this just to make demos clear. So, which brings another good question. Should you ever include the clustering key in an index? I like doing it if I'm the developer and not the DBA, because the DBA could later change the clustered index strategy behind me. He could move things around so that the table's stored in a different order. And if I constantly need that ID field as part of my app, then I may want to explicitly say that in my index. But if you're just using it to get back to the clustered index, who cares? If you're not actually using the ID field in your app. Let me jump back over here, put the page back up before I take questions again here. No, not you. You're nice. I love you to death. You're sweet, but okay, yes. More questions? Yes. Great question. Where are statistics saved and how big do they get? And I know what your next question is going to be too. So these are saved in the user database. Each stat takes one page, so just 8K. They're very tiny. Your next question is, how much overhead is there as I add additional stats? See, right? Every now and then I get these things right. So they do take read work in order to update, because I have to read a whole bunch of pages in order to update the statistic. But I'm not writing much data. This isn't an intensive transaction log operation. I'm just reading a lot. So why not put stats on every single column then, right? Well, I don't know if I'm going to actually query every single column, and SQL Server will automatically create the statistics for me anyway. So I don't like overthinking or premature optimization. I'll just let SQL Server go and create those statistics. And I'll also say that during my work as a database administrator, I have never manually created a statistic. I'm not saying you might never need to. There are people in this room who deal with larger databases or faster databases than I do. But I don't usually have to go to that depth because SQL Server will automatically create the stats it needs anyway. More questions? Yes. Oh, I didn't predict your next one after that. Man, I suck. Yes. Wow, the question was which file group are they saved in? I actually don't know the answer to that. That's really interesting. If you want, email me that and I'll go find out an answer real quick. That's pretty easy to check. So, yeah, that's kind of curious. Yeah, well, yeah, I would think it would be stored in the same one as the index or primary, one of the two, but I don't know for sure, and I can find that out really easily. Yeah. And if half your file groups are unavailable, then I'd focus more on getting the other file groups available before I'd worry about performance anyway. I'd say, of course, performance is going to suck. What else? More questions on stats? Yes?
Great question. So because of this data, why is it that both distinct range rows and range rows are the same in all of mine? Well, it just so happens that this is time data based on when Stack Overflow users logged in. And during this period, no two users logged in at exactly the same time. Now, if I was looking at the current login history, because Stack Overflow is much more popular now, I would have dozens or hundreds of users that logged in at exactly the same time. So range rows would be smaller, range rows would be larger than distinct range rows. Yeah, great question. More questions about this? Yes.
Talking about sizes,
Oh man, why'd you have to go into the religious question? So the question was, should you use GUIDs as clustered indexes? So let me tell you first, if you've got an existing database that's already built and you're trying to deal with performance problems, using GUIDs as clustered indexes probably isn't your biggest problem. You probably got a lot of other things you need to focus on. Don't rewrite the database or make massive, data storage changes to make the clustering GUIDs go away, because that's probably not your biggest bottleneck. But if you're going to sketch out a new database from scratch, there's a pretty good argument to be made that the clustered index keys should be unique, narrow, static, and ever increasing. Exactly describes an identity field. That's exactly what the kind of things that I would aim for. And of course, Microsoft, in all their brilliance, identity fields are not supported in Hackathon. If you want to use the new data storage, which is really funny because it's all about extremely fast performance, and then they throw GUIDs in the mix and it makes all DBA's skins crawl. So for existing databases, I don't worry about it. Keep doing what you're doing. For new databases from the ground up, if you're not going to move to Hackathon, I'd stick with identity fields. That was going to lead me into something else. Oh well, somebody else's question will remind me. All right, any more questions? And I can go all day. Who cares about the next person? They're on their own. We can run as long as we want. All right, so we covered that one already. Statistics help SQL Server choose whether or not it should do seeks or scans, which indexes it should process first, because notice that as I've been going through here, we did lookups back and forth. We looked at this one first, then we looked at this second. That's really what joins are like. These could be two separate tables that we're joining together. SQL Server functions exactly the same way. Everything's an index as far as we're concerned. My favorite part of that, though, is the last one. SQL Server uses statistics to project how much memory it's going to need in order to execute your query. Because as I mentioned earlier, SQL Server uses memory for three different things: caching data, caching execution plans, and having workspace for your memory. And we don't get any kind of knobs to tweak those, but if our stats are up to date and accurate, SQL Server can make much better decisions. I want SQL Server to accurately estimate how much memory I need. So let's take a look at where we see that in SQL Server Management Studio. I am showing you Management Studio 2012. You should be using this even if you're connecting to older versions of SQL Server. I'll give you the link to get it for free. Microsoft now makes this totally available for free, whether you're licensed for 2005, 2008, whatever. So I'm now looking at an actual execution plan, not an estimated execution plan. And the way that I can tell that is here I've got results, messages, and execution plan. So what I did was I ran this query, and before I did it, I clicked Query Include Actual Execution Plan. So SQL Server, I'll have another drink at lunch, please. SQL Server showing me exactly what it did here. If I right-click on the select, the root node there, and I say Properties, it opens up a Properties window on this side. This is what's cool about 2012, where SSMS 2012 starts to surface a little more information that we don't have to go scrounging through the XML in order to get. On the right-hand side, I see memory grant info. Other small piece of trivia there, optimization level. When I see full, that tells me that SQL Server really worked hard in order to build a good execution plan for this query. When I see things like early timeout, I gave up, that tells me that SQL Server only looked at the first couple of possibilities and then said, good enough found, I'm out of here. This is as close as I'm going to get. When people tell you that join order doesn't matter, that's true only if you get full optimization or trivial, meaning it was so simple of an execution plan that SQL Server said, well, that's elementary, Watson. There's only one way I could accomplish this. But when you see timed out, that tells you that by rewriting the query, you may be able to influence what execution plan options SQL Server tries first, and then you can get a different execution plan. In this one, we're focusing on a memory grant info, and if I expand that, it shows me desired, how much memory this query wishes it could have had when it ran, how much it actually got, because it could get a half or less if the SQL Server is under memory pressure. When your query takes flight, the amount of memory that you've got is capped in stone. You don't get additional memory if more rows come back. Your results are instead written where? TempDB. So you guys just, I'm surprised nobody said public toilet. I haven't trained you quite well enough yet. So SQL Server is going to end up bailing out and throwing that data out into the public toilet. I told you so. The amount of maximum used memory by this query, how much it would have actually required, the bare minimum it needed in order to get to run, and then other info about if we were going to run this query serially instead of in parallel. You don't have to really dig deep into memory grants, but just knowing that this stuff is out there helps you determine whether or not your queries are doing well. If you're bringing back gigs worth of data, you're not going to get that kind of memory, and you're going to be writing your data off to TempDB. Easiest to see in SSMS 2012, so there's the link in order to download SSMS 2012 for free. If you go to brentozar.com/go/get SSMS, it takes you to the download page on Microsoft.com where you can get it. They're a little tricky with that. You have to scroll down some in order to see what package you're actually getting. Small side plug there too, SQL Server Management Studio needs to be patched just like SQL Server does. There are plenty of known bugs in SQL Server Management Studio that display things incorrectly in the execution plan. So you want to download the latest service packs for SQL Server Management Studio on your desktop as well. Little info about the memory grants, and then of course we dump the stuff into TempDB. So now, what if I am constantly querying by last access date and display name and age? You don't have to pass these around, but this is the gray page. I've decided to create another set of indexes here. Either of the creates that I'm showing up at the top will produce these same leaf level pages. These are the pages in gray here. So I've got all of the users ordered by last access date, then ID, then display name and age. There's religious feelings in the SQL Server community about whether or not you should do things in include or in the keys. The top one sorts all four of those fields in order. The bottom one sorts them by last access date and ID, and then also throws in display name and age, but does not sort them. So that when Nick Bradbury finally decides to put his age in here, it doesn't move him around. But it wouldn't have moved him around anyway because I'm sorting by last access date, then ID. ID is unique in this database, so if either of these two things changed, it's not like it would have pushed it up or down. I have the same impact in here when I'm updating those fields. But if somebody decided to display or change their ID, then I would actually have to move them around, or maybe even more importantly, every time someone changes their last access date, I am going to be moving them all over on both of these. Last access date in Stack Overflow is whenever this user last logged in. And because our users just love us to death, they're constantly logging in, and I am constantly picking up people and moving them to the end of the index. Last access date is a hot field, meaning it constantly changes. I don't want to index something like that constantly changes unless it's absolutely critical and I know I have to have it. There is nothing in SQL Server that will tell you which fields are hot. That's something that you have to discover through looking at the business use of the application. Told you it was a science, not so much of an art. So now I have 3 copies of my table, or rather you have 3 copies of my table, the clustered index, the gray index, and the black index. I'm going to give you a query. Select ID, display name, and last access date, order by last access date. This is really pretty simple now that you have the gray copy. It has all of those fields. SQL Server tracks in the index usage DMVs how often every index gets accessed. Let's pretend that our SQL Server just rebooted and you ran this query. The gray index would get exactly 1 use. It has been read 1 time to make your queries go faster. So we'll think about that. We'll put 1 down for the gray index. Now I'm going to turn around and run this query. I'm going to select just the ID, but not display name and age. Which index does SQL Server use? Does it use the gray one, or does it use the black one? SQL Server is going to use the black one because it's a narrower copy of our data. It may take slightly less work in order to accomplish this query with the black page. SQL Server has no idea that we just read data out of this index. SQL Server doesn't think this one's cached, I should use this. SQL Server builds execution plans based on what's theoretically perfect. So now both of these indexes have a use recorded for them. If I query the index usage DMVs, they will both show 1. That's bad. I actually only want to use one of these 2. Which one? The gray. Because the gray index would satisfy both of those queries. Sure, it's a little bit wider, but it'll give me the 2-for-1 bang for the buck. This comes down to one of my favorite quotes from Colin Chapman. He's a Formula One car, just brilliant innovator back in the 50s, 60s, and 70s out of Britain. Invented Lotus car, started Lotus cars, was founded Aerodynamics, all kinds of stuff. He liked to say that, and this is not the quote I'm going to talk about, but he liked to say that race cars are only useful if they can win. A race car that is safe but can't win is useless. As you can probably guess, a lot of his drivers died, didn't do so well. But he won a lot of races. And one of his other quotes was simplicate and then add lightness, meaning strip everything you possibly can out of the car in order to make it go fast. I need to dump that black index because it's just holding me back every time I do an insert, update, or delete. That's 1 extra copy of the table that I don't want to be playing with. When you're doing index tuning, you want to ask yourself, what would Colin Chapman do? How would he handle these indexes? He would wad up that black index and throw it away. He would also put his database in simple recovery mode and not take any backups because he wants the thing to run fast. Maybe you shouldn't think about that when you're doing reliability tuning. SQL Server's index usage DMVs will get you some of the way, but not all of the way. And knowing how these indexes work, how SQL Server chooses to use them, and how SQL Server uses statistics will help you be a better performance tuner now. SQL Server is doing all of this decision-making work for every single table in your query. SQL Server has to build this big, ginormous map of how it's going to access the data, in which order, how many rows it expects to come back. Because this stuff is so computationally intensive, SQL Server stores all of it for you in the plan cache. Well, it doesn't store it for you, stores it for itself. You can then go back and query that to find out which queries are the most expensive, how many times they've run, how often they've run, frequency in terms of minutes, how many CPU cycles they did, how many logical reads they did, and much more. So when you leave out of here and you want to start your next part of learning, start investigating SQL Server's plan cache. There's 2 free tools you can use to analyze this. Both of these are tools for me, actually. SP Blitz gives you this analysis of your plan cache over time and says, you have these 20 really ugly queries in your plan cache. They all have missing index warnings. Go check these out. There is no performance overhead to querying this. SQL Server's already grabbing this data for you, and all you have to do is query it. Takes less than 5 seconds. Same thing with my other new one, SP Ask Brent. This looks at your plan cache, takes a snapshot of it, waits 5 seconds while your SQL Server does work, and takes another snapshot. Compares those 2 snapshots to see which queries ran the most often, used the most CPU time, did the most logical reads. So then you can quickly jump in and shows you the execution plans so you can start using what you learned here today and figure out how to make those things go faster with index tuning or better sargeability. So to narrow down or sum up everything that we talked about here, narrower indexes like my black copy are very small and hardly take up any space, but they're not very useful if they don't cover all of the fields that my query needs. I have to figure out what the balance is between wide indexes and narrower ones. I want to rip out as many duplicates as I possibly can. I want to pre-sort my data, start ripping out some of these extra dead weight. Statistics help make SQL Server help SQL Server make good decisions. Keeping them up to date with manual update jobs, stuff like Ola Hollengren scripts, running your update stats weekly will get you a much better picture of how your database works and help SQL Server build really good plans for you guys. So thanks for joining me today. I'm going to wrap things up here because I'm right on time. I will take questions out in the hallway, but you guys can go head out to your next session and I will see you out in the hallway. Thanks a lot, everybody.